When a lithium-ion battery catches fire, it doesn't behave like a normal fire. And right now, the biggest cause of these incidents in homes and apartments isn't phones or laptops. It's e-bikes and e-scooters. These devices are behind some of the most violent and fast-moving residential fires we're seeing today. And in this video, I'll explain why and what it means for fire protection engineering in Australia. E-bikes and e-scooters use large lithium-ion battery packs, much bigger than anything in your phone or laptop. And when something goes wrong, the reaction is far more extreme. When a cell overheats, it can trigger a chain reaction called thermal runaway. One cell fails, then the next, and the whole pack releases huge amounts of heat, flame, and toxic gases within seconds. The biggest danger is where these fires start. People charge these devices inside their homes, bedrooms, hallways, lounge rooms, often blocking the only exit. When a lithium-ion battery fails, a room can be fully engulfed in under a minute, leaving almost no time to escape. A major issue is the number of cheap, non-compliant e-bikes and scooters being imported online. Many use low-quality cells, poor battery management, fake certification labels, and chargers with no safety cutoffs. Most fires start while charging because nothing is stopping the battery from overheating, overcharging, or short-circuiting. Once a lithium battery enters thermal runaway, traditional fire systems struggle. Sprinklers can cool the area and slow the spread, but they can't extinguish a battery that's generating its own heat, oxygen, and flammable gases. Even after the flames go out, the battery can reignite minutes or hours later. Fire brigades across Australia are seeing the same pattern. Many have released position statements highlighting how quickly lithium-ion battery fires develop and how difficult they are to control. Their advice is consistent. Don't charge mobility devices inside apartments or hallways. Don't block exits with them, and avoid cheap or modified battery packs. Damaged or swollen batteries should be treated like hazardous materials. Another challenge is that there is currently nothing in the Australian standards that specifically deals with lithium-ion battery fires. Our fire systems were designed long before e-bikes, scooters, home batteries, or EVs became common. Water is still the best way to cool a battery in thermal runaway, but the amount required is huge. Fire brigades may use thousands of litres of water just to stop reignition, and sometimes the device needs to be submerged. This runoff water can contain metals, electrolytes, and toxic byproducts. Electric vehicles face the same issue on a larger scale. Their battery packs are far bigger, and some electric vehicle fires overseas have required tens of thousands of litres of water, with cars submerged in tanks for days. Again, nothing in our standards directly covers EV fire behaviour in basements or car parks. Because of this, Queensland fire authorities now recommend that any project with electric vehicles or chargers in a car park includes a simple special hazard assessment that just means a fire engineer reviews the risks, checks whether the building's fire systems can actually deal with an electric vehicle fire, and recommends anything extra that might be needed. If this assessment isn't done properly, the fire service can say the design is not suitable, meaning it can't be approved until it's fixed. For fire protection engineers, all of this means the risks we're designing for are changing fast. We're coming up with different solutions on almost every project because there isn't a single proven approach that works for all lithium-ion battery fires. Some projects use tighter sprinkler spacing to deliver more water. Others rely on earlier detection, off-gas monitoring, or stronger mechanical exhaust. Some buildings need protected charging areas, while others require performance-based design. Right now, there is no one-size-fits-all solution. And the biggest challenge isn't actually electric cars. It's mobility devices like e-bikes and e-scooters. Electric vehicles are fixed in predictable places like basements and car parks, so engineers can design around them with sprinkler coverage, hydrant access, exhaust systems, and structural separation. E-bikes and scooters are completely different. They can be charged in bedrooms, hallways, lounge rooms, storage cages, basically anywhere a power point exists. That unpredictability is what makes them one of the highest emerging fire risks inside residential buildings. Thanks for watching, and don't forget to subscribe for more fire protection engineering videos.